Hello, welcome to the Creature Game Engine Export tutorial. This tutorial is going to give you an overview of all the file formats and methods you can use to export your data to your game engines in Creature. Now, to start off, I like to say that there are two kinds of major formats that Creature supports for game engine export. There is the generic export format, all right, and that composes the generic formats that are supported by not just game engines but major, say, 3D tools, Houdini, Maya, 3ds Max, that sort of thing, and those compose of the FBX file format and the Alembic point cache file format. And then there are the runtime export formats. The runtime export formats comprise of the native or the default Creature runtime formats. They are what Creature supports itself, and they are in the JSON format or the Flatbuffers, Google Flatbuffers binary format, or the Creature Pack binary format. So there are two major formats, the generic ones and the runtime export formats. And depending on what your requirements are, you can pick either or, right? If you want to go with the more generic ones, you just go with FBX and Alembic because those are probably much easier to integrate. Okay, so let's start off with FBX. So this is the FBX file format. Let me start with the FBX file format. The FBX file format is a generic skeletal mesh skinning format. It does mesh deformation via skinning. Okay, that's what I emphasize. So there's no mesh motor deformation. What do I mean by that? So you don't get FFD, full frame deformation. You don't get like the blinking motors. You don't get the flap motors. So it doesn't have support for mesh motor deformation. It does have mesh deformation, but all of the mesh deformation has to be done through bone motors. All right, that's the key difference. However, the advantage of it is that it's GPU accelerated, and usually it's very, very fast. So if you wanted to use a very fast game engine supported file format by default, you should pick FBX. And if you don't use sprite swapping and you're not using mesh motors, then the FBX file format is perfect for you. So that's FBX. Now moving on to Alembic. Alembic is almost like the opposite of FBX. It does not have bones. There's no bones in Alembic. It's a pure point cache. However, all the motors are supported. All bone motors, all sprite swapping, all mesh motors, so everything's supported. And so that's the advantage of it. It might be a bit larger than FBX depending on how you do the export options. However, there are options in Creature to help you compress down the size of the Alembic file format, so it might not necessarily be larger, but crucially there's no bones, which means that if you want to do some kind of attachment, you're going to have to do it on a per vertex basis. There are no bones for you to do attachments, or if you wanted to, say in real time, pose the bones somehow using your code, or overwrite the bone positions of Alembic, it doesn't exist, right? You're not able to do that. Lastly, both formats are not just supported in game engines, but they're also supported in third-party tools like Maya, Houdini, 3ds Max, which is fantastic. So if you wanted to bring, say, a mesh authored in Creature into a third-party animation tool, a third-party 3D tool, you can do that in either file format. So that's the big, big plus of both of these generic formats. And they drop in, integrate into the game engine extremely easily because you're actually using the game engine's default tools pipeline. So that's another fantastic thing. So I'm going to show you demos of both FBX and Alembic. Right, so here you see FBX in action. Here is the raptor on the lower right of the screen, and this is an FBX exported character from Creature running in Unity. Right, so the raptor animation is pure bone motors only, which makes sense. So this makes it a perfect candidate for FBX. So here is essentially FBX in action in Unity, and you can see the same thing in Unreal Engine as well. And here is an example of Alembic running in Unreal Engine. Here's a character that's authored with both bone and mesh motors, so it's deforming everything. There are bone motors deforming the mesh via skinning for the physics, and then there's mesh motors that's turning the character in a fake pseudo 3D fashion. So the whole thing is running in Alembic very smoothly right now in Unreal Engine. Okay, so moving on to runtime formats. So these are the runtime formats that Creature actually exports itself. They're different from the generic file formats, and the big difference is they offer you a lot more control. They have a lot more gameplay features in it. They allow you to do real-time, say, swapping of images or slots or sprites of the character. You can control them more easily, you can do animation blending much more easily, and all that, because there's more functionality, there's more built-in gameplay functionality. You can do attachments. Now, there are three kinds of files that are exported from Creature. There is the JSON, the original text JSON. There are the Flatbuffers binary file formats, and then there's the new fancy Creature pack format, which I will cover as well. And obviously, these runtime file formats are supported in all major game engines. As you know, Unity, Unreal Engine, Cocos 2DX, libgdx, MonoGame, WebGL, JS, etc. There's a ton of game engines that it supports, and you can always grab the runtimes from this address over here. So please head over there and have a look. Now, the JSON or Flatbuffers formats are really the same. Now the JSON format supports all functionalities of Creature, everything: bash motors, bone motors, sprite swapping, gameplay, attachments, that sort of thing, everything, all motors. The issue with the JSON format is it might be a bit slow to load or parse on non-native game engines. What do I mean by that? Well, if your scripting language in that game engine is like C# or JavaScript or Java, that sort of thing, then it might be a bit slow because those languages are not natively compiled on the system. So that would be Unity, libgdx, WebGL, and JS. So they might be a bit slow. However, it's good for debugging because it's a text-based format. However, the C++ game engines work fast on it, like Unreal Engine. So it's actually fine. Performance on Unreal Engine and any C++ engine for JSON is actually quite adequate. In some cases, really, really fast, because they are natively compiled. So the alternative for the non-native game engines is the Flatbuffers format over here, this guy over here. And this is essentially just a binary variant of the JSON format. It's a bit smaller, but the key thing is that it loads much, much faster on non-native game engines because there's less memory allocation and that sort of thing. But it offers the exact same functionality as the JSON. In other words, both of these guys offer the full functionality of the Creature runtime. So if you need all the functionality, everything, real-time IK and swapping of images or the attachments in-game, use the JSON of Flatbuffers. And in the case of Unity, MonoGame, libgdx, and WebGL, I highly recommend you stick to Flatbuffers because the load times are reduced tremendously. And an example of the Flatbuffers format in action is the Creature platformer. This is a simple demo that is authored in Unity using the Flatbuffers JSON file format. You can see there's a lot of things going on here, and it's very, very performant actually, and it's showing off all the gameplay features that are possible with this file format. Right? There's AI moving all the characters around. You can control the character, you can jump, you can change the motion. It's all very cool. So this is an example of the flat bar. You can do collisions, so see how it actually hits the ground as well. So this is an example of the JSON Flatbuffers format in action, and so you can use this when you need full gameplay features, like so, right now running in Unity. And similarly in Unreal Engine, here is the JSON Flatbuffers file format in action, and here is a really, really amazing, I think, great demonstration of what it can actually do. Now you have 3D objects like screen space reflections of the water interacting with all the characters on screen you see right now, the bridge, the helicopters, the planes, the big angry lizard itself. They're all authored in Creature and exported out into Unreal Engine, and it's running through the blueprint system. From here let me open up the blueprint editor, and you can see there's a lot of controls going on for the different characters, and this again is running off the JSON format in Unreal Engine using the Creature Unreal Engine plugin, right? Okay, so this is a very good demonstration of what it can do. So if you need a full functionality, full gameplay functionality of the Creature file formats, if you need Creature characters, then please use the JSON or Flatbuffers format according to your engine, since you need all the gameplay features. Okay, and moving on to the final file format. This is the Creature Pack file format. So what's that? Well, this is a brand new runtime point cache format. It's a bit like Alembic, but it's Creature's own point cache file format. There's no bones, just like Alembic. It offers a bit less functionality, but a bit more than Alembic. So there's still some basic gameplay features that it has, like animation blending, for example, and it also supports attachments in, say, the Unreal Engine creature pack runtime using vertex position. So it offers a bit more functionality, a bit more gameplay functionality, and just like any point cache file format, all multers are supported. That's a great thing. All bone, mesh multers, sprite swapping is all supported. The advantage too, the real advantage is it's super fast, and it can be optimized for low memory devices. So it takes less memory if you can actually compress it down. If you actually tweak the options, you can actually reduce the size of the export, and it's super fast. The playback is super fast. So it can be optimized for smaller file sizes for low-end devices, which makes it fantastic for background characters and crowds. If you have tons of characters or background characters that need to move about on screen, like trees or bushes or any kind of background effect where you're going to throw tons of these characters, I recommend using the creature pack file format, because you will be using less gameplay functionality, but you can have a lot of characters. And currently, right now, it's supported for Unreal Engine, for Unity, and WebGL. So I recommend you taking a look at this file format as well. Here is the best example of the creature pack file format in action. Now these are hummingbirds flying over a bunch of flowers, a bunch of plants in the background. Every single character or object that I can name in this scene is authored completely in Creature. So everything now was authored in Creature and exported out. Like you can tell, there are a ton of characters. There's birds flying the screen, there's a lot of flowers, there's tons of meshes. And this is actually running in Unity WebGL. In other words, it's actually running in a web browser at this speed, at this frame rate. So the creature pack file format is so performant, it can actually run extremely smoothly with so many characters on screen on even like low-end devices at a really high frame rate. So again, I highly recommend, if you are memory constrained or you need really high performance because you're throwing a ton of crowds characters, to consider the creature pack file format for your game or your application. Now, when you want to export to a game engine in Creature, what you do is you move your mouse over to the Export button, and then you click on that, and it says there's two options: images, video, or game engines. Obviously, you pick the game engines option, and this gets you to a screen which gives you tons of options for export. Right? And I recommend, first of all, that you probably want to set frame ranges if you want to customize the export frame range. If you want to cut off the custom frame range for looping and whatnot, you should first set the frame ranges for export. Okay, and that should reduce your file size and also help you do some looping if you figure out the best looping frame range. Okay, and the other options are actually covered in the documentation online, so you probably don't have to muck with too much of that, right? But you might want to check the counterclockwise order if your drawing routines are counterclockwise. But these options you probably don't have to touch for now. Now the creature pack web format options are covered again on the online docs, and they tell you how to tweak and crush or compress the sizes, the file sizes, the export file sizes down. So you should really take a look at that as well. So these options are important. And finally, when you're done, you just click Export. There are two options, right? You can either click Normal Export if you're on the regular version of Creature, but if you're actually on the Pro version, I highly recommend you using the Advanced Export. And what does it do? So let's click on that and find out. So the Advanced Export looks, similar. It looks like a regular export. What does it do? Well, you can check wireframe, and you can see that this character has a very high mesh complexity, which means when you export it out to a game engine, you might be spending a lot of time rendering it, or the file size might be quite large because it's got a large file. So what you should do is you should use the Advanced Export to actually decimate the resolution of the creature mesh. So I can tweak this slider, and I can reduce the resolution of the character. And now you can see that the mesh has been now reduced to only 30% of the original. If you uncheck the wireframe, you can see that the quality is actually quite well. It's actually quite preserved really well, right? So that's the cool thing about the Advanced Export. So it allows you to essentially author in high resolution, which is what you want, which is what artists want, and then export out into your game engines at a much more reasonable resolution, so that you can actually have good performance, and that gives you the best of both worlds. So I highly recommend you using the Advanced Export to optimize the mesh export of your characters in order to get much better performance in your games or applications. Right, so now let me cover the results of your export. Once you've done the game engine export, what it does is it tells you to pick a directory or folder in which it writes out all the output or the results of your character. Now, when you open up the folder, here's an example folder. You're going to see a bunch of files. Don't worry, don't panic. They're all very useful things to know. Okay, so let me go through what each of these files mean. The first file you see is the .abc file. That's the Alembic file. So if you're going to do Alembic and use Alembic, you pick that file. The next file is the .bytes file. That's the Flatbuffers file. So if you're going to use the Flatbuffers version of the full runtime format, pick that file. The next version is the creature_pack, which is obviously a creature pack file. So again, that's a creature pack file over here. And then there's the default JSON file, which is useful, the text-based JSON file if you're going to do some debugging, or actually if you're using a C++ game engine, it doesn't matter because it's actually fast enough to parse it. So go with the JSON file. And then there's the mdata file. That is the metadata file. So as covered in the previous tutorials, please look online for them. These files are used if you're doing layer order animation or you're doing events like sound events, that sort of thing. So that's the mdata file. Again, optional file. This is an optional file. And then lastly, there is the png file. That is the character image atlas, texture atlas of your character. So very important. Don't forget that one. You always want to import that because that's going to be used to display your character. That is the texture atlas. And finally, if you're doing FEX export, it's actually done through the image video option because that was an earlier option. We can shift it. We can move that option to the game engine export soon if you want. But in any case, you can do FEX export through the image video export button, and that will take you to the options there. And as I covered before, I showed you in the advanced export, I highly recommend again that you optimize your export meshes if you're using Creature Pro, because this allows you to reduce mesh complexity and allows for much better playback performance. So yep, that basically covers this Creature Game Engine export tutorial. I hope it was very useful and informative, and these are some really good guidelines that you can follow to help you optimize the performance of your characters in your games or your applications. So I hope you had fun watching this tutorial, and happy animating.